Alright, hello friends. So, this is the main programming lecture of the week, and we're going to talk about functions quite a bit, because they're very powerful things. We will make some more of our own, and I'm also going to try and get us to animation this week as well. So, not just drawing things with turtles. I guess the turtle itself is animated as it draws, but we can go further. Okay, so let's get started by remembering what a function does, how it works, why it's so powerful. So at the end of the day, a function is just a piece of code that gets run multiple times in multiple different places and saves you a lot of typing because you can rerun it. So and it has a bunch of arguments that you can give when you call it, and so it has many parameters that it takes. So it takes parameters and it gets called with arguments. Those are the two different terms that are kind of very similar. The arguments get filled in for parameters. And so in Python, it's always, you say def, then you say the function name, and then you give your arguments. There. In the definition, they're called parameters. Even I get these names mixed up from time to time. So you can have multiple parameters, and you give your colon, and this is all supposed to be on the same line. I'm just a little strapped for space. And then you tab over, as normal, for blocks in Python, and, well, you can start giving the body. Body line 1, body line 2, and then you can dedent yourself. The opposite of indent is dedent, apparently. And then out here is just the rest of the program. And eventually you can call your function with arguments. And when it goes and jumps to this code as it runs it, arg1 will be stored inside of param1. So param1 is a variable that exists inside of this function. And it's going to be set to the value of arg1 for the particular call right here. Okay, same with param2. It gets set to the value of arg2. So you're allowed to pass along these values and use them in the body of your code. Okay, so that is the beauty of a function. So you can rerun it, and it can take as many parameters as you want, and you can fill those in each time you call the function with different values. Okay, so that's a very powerful concept. Okay, so just remember your syntax. Remember how to define a function, and then also to call that function. In addition, one last thing, a function can return a value. Back to whoever called it. And that value can then be used in a larger expression. Some functions just do stuff and don't return anything. Okay, and we'll give some examples of a lot of the doing stuff today. So yeah, as an example of returning and using a value, it's like you call your function, I guess it's called funcname in this example, with like 42 and 43, and then you can immediately add 1 to that because it returns value, if it returns a value, that is. Okay, and you can have multiple return statements. So that's the idea. Those are functions again. And now let's make something normal. Let's make a draw rectangle function. So what would we like? it would be really nice if we had a function that could draw a rectangle for us. But how do we specify that rectangle that we want to draw? What parameters should draw a rectangle have? That is, how do we want to call this function? Draw a rectangle. What do we want here? And okay, we need to now think about what it means to be a rectangle. Like, how do you fully describe a rectangle in space? Okay, well, I think you can imagine that you might need at least a width and a height. That describes a rectangle. But also, you need to know where this rectangle is, because, I mean, if it's got a width and a height, I can just put it over here just as easily as I can put it way up here. Okay? So you also need a starting point for this rectangle. So maybe if we give one of the coordinates of the corners, then we have a location. Okay? So this actually fully describes a rectangle. I hope it makes sense. You tell it where it starts. Tell the rectangle, hey, your upper left corner is right here, and then it's fixed there. And then you give a certain width, and then you give a certain height, and there's only one rectangle with all of those being the same. Okay? The location of one of the corners. You just need a coordinate somewhere. Technically, I mean, you could store the coordinate of 1/3 of the way down the left side if you really wanted to. But you need a point to pin down this rectangle. And so we'll use the coordinates of the upper left corner. And then also we need the width and the height. And that fully specifies a rectangle. And then we can make our function. We do def draw rectangle. We can get the coordinates like of the upper left corner. We'll call it UL. And we can give it the width and the height. And I can barely fit it in there. And then we'll tab over and start doing stuff with turtles. Okay, so hopefully that all makes sense. We're going to make a function called drawRectangle, and it'll draw the rectangle for us. And we need to specify what it means to be a rectangle, though, so that we always draw the one we wanted. Okay, so let's go to code now and make this work. All right. I'll call this drawRectangle. We're going to have to import turtle, that's for sure. So def So what we want to be able to do is be like, okay, draw a rectangle with the upper left corner of like 50, 25, with width 100 and height 200. Okay? That's the idea. So that's how we want to use this function, and we'll make it so that it does exactly that. Okay? And you can pass along a coordinate as a single variable, and that's using a type called a tuple. This is how you make a tuple. You can do like 1, 2 with like that is a tuple. 1, 2, 3 etc. Those are all tuples, as big as you want. It's essentially lists with those brackets replaced with parentheses. Slightly different. So here's a tuple, like 1, 2, and you can store it in a variable, just like a list. 1, 2, x, it's that. What's the type of x? It's a tuple. Okay, that's the idea. You can access it just like you would a list. You can be like x of 0. Hey, that's the first thing. X of 1. Hey, that's the second thing. Okay, so that's important. Dun dun dun. And yeah, so maybe so you don't forget, I can take a screenshot of that. Whee. Those are tuples. I'll put it, don't know where. I'm gonna put it somewhere. Maybe I'll put it over here. There. Okay, so let's make this draw rectangle function now. So starting in the upper left, we need to get the x and the y coordinates of the upper left. We need to tell the turtle to go there. Okay, since UL stands for upper left, it's a tuple. It's got two things. We're forcing it to always have, if it was used correctly, an x and a y coordinate. And turtle's goto function is going to put it right there. Oh, no, sorry, turtle. It takes an x and then a y. Okay. So, now we're ready. It's going to go to that location. Now we need to draw the rectangle. We put the turtle here. We have no clue which way the turtle is currently facing, so we better start the turtle facing that way. How about that? Face the turtle east. How do we make the turtle turn in a certain direction? Well, we can say left and right, but we're not sure which way he's currently turning, so we can say set heading, or set H, okay? Which will turn the turtle in a given direction. And we are in standard mode, so it'll be east. 0 is east. Okay, then we'll draw the rectangle. Turtles, we now know, moving that way. So let's have him go forward width. Turn left 90, or turn right 90 degrees. Now he's here, facing that way. We gotta go H now. Go forward by height. And then turtle dot right 90. Because he's here, now facing that way. We need to go width again in that direction. Go forward the amount of width. And then we need to go turn right one more time because we're here facing this way. We need to now turn this way and go height once more. Okay. And suddenly we have a rectangle. Okay. Let's see here. How do we want to do this? I think, yeah, let's try this. Let's see what's gonna happen now. Save, run. Yeah, we drew a rectangle. Oh, but the turtle, he started out down. And then when we went to the direction, or we went to the location of the rectangle, oh man, the turtle was drawing a line still. So we should, before we go to, pick up the turtle. So we'll say turtle.up. After he's gone to the right spot, we can say turtle back down. And another thing, we can color our rectangles as well. There's a rectangle. Here's another one. How about 75, 50? So here's two rectangles now. So we can reuse our function. It's beautiful. It's working. We can make our rectangles colored, maybe. We can say, all right, the first one is red. The next one is blue. And so we can give another parameter here, color. So it actually changes these colors. So how do we do that? Well, we just have to change the color for the turtle now. So if you remember how to do that, we also have to use begin fill and end fill, and the color. Fill color. Okay, I have to say turtle dot fill color. Set it to the color that the user gave us. Color goes here. Then we need to begin fill. And then after we've drawn a rectangle, end fill. All right. So we got a red rectangle and a blue rectangle now. Isn't that cute? So hopefully this is all making sense. Functions are really nice in that they can break up the monotony. I can call this draw rectangle function as many times as I want now, and I'm going to have beautiful rectangles. Okay? Of a given width and a given height, a given starting location, a given color. This is all so nice. Okay, so that's rectangles. Let's now get back to, you remember your original assignment where I told you to do like your initials and then your graduation year? Well, you kind of hard-coded everything, didn't you? Let's make a way very similar to draw rectangle. Let's make a way to resize letters. I'll make an N character that's resizable, okay? So the idea is we can bound every letter inside of a rectangle. Which shouldn't be too hard to imagine. Like, here's a very long N, and here's how you bound it in a rectangle. Draw the rectangle, then here's where the N would go, right? If I gave you a different rectangle, you could also fill it with an N. Because you go to the corners, go diagonally, and then go up. You can do this for every kind of letter. You can bound it in a rectangle. And so all of these are going to have widths and heights, and you can pass those along. You just have to worry about going to certain corners. So, given a rectangle to fill with the letter, we can draw any character and have it take up that space. Okay, so I'm going to copy most of what I just did for draw rectangle, and we'll make a new file called draw n, I guess. So I can close that one. And now, I don't really care about color anymore, so I'm going to get rid of the filling and the colors and things. But I still want to draw a bunch of ends over here, so that's how we're going to do this. Let's see here. So I'm going to draw my last initial, and I'm going to draw it twice, just where we were. Again, okay. L is too easy. I guess N is a bit more complicated, so I picked that one. Let's see here. So again, you specify the rectangle that you want to draw the N in. So how do you do it? Well, you're going to start. You know you want to be in the upper left corner. That's where you start. And then you can move appropriately. So actually, I guess you don't have to technically start there. So here's the idea. Here's your bounding rectangle. And here's what you want to draw. You want to draw the n. Boop, boop, boop. So this coordinate you're given, so that's your, if ul equals xy, you start at xy. What's this coordinate then? And we were also given a height and a width. This coordinate right here, well, the y has changed. Same x, y minus h. You see that? This is different x, y plus the width, x plus the width. And then also y minus h. And then this corner is x plus the width. Oops, not x plus y. And then the original y, because that was the upper left. You see that? That's super nice. So, with that in mind, let's draw the n. Let's see if I can put it over here. Yay. Erase that comment. And these are n's now. So, I'm going to do all the same stuff. I guess we don't even need to change the heading actually anymore because we're going to use go-to every time. But the idea is, let's get the x and the y out of the ul. And now, let's use them to our advantage. So let's draw the n like this. So we want the turtle to originally, let's draw the n like we normally draw an n from the bottom, just like that. So we want to start, go to x, comma y minus height. Okay, so we're going to start here, then go here, then go here, then go here. You see that? Isn't that cool? I guess I want to put the turtle down first. I just realized what I just said. You know what I meant. X plus width, y minus height. Then we want x plus width, y. No, sorry. We originally, I was going in this direction. Trying to go up here. Start at x, y minus h. Then have the turtle put its tail down. Then we'll move to xy. Then we'll move to x plus width, y minus height, and then finally we'll go back up to x plus width, y. Oh no. Come on. There we go. Okay. Let's see if I made any mistakes doing that. No. Okay, you see how we can have many different n's now, and you can do this for any letter. Okay, so that's fun. And then the final thing I'll probably only have time for today is to talk about dropping balls. So we want to animate things finally. So here is how an animator might animate a ball that is dropping. We're going to just consider it on one dimension. So like the ball is going to start here, move up, then come back down just on top of itself. So if I can draw it over here, maybe I can use my mouse to show you. We're just going to have it bounce straight up and straight down. Okay? So that's going to be our first goal. So, are you ready? Well, I'm going to have to talk about a little bit before we get started, though. So, just to get us all on the same page, this is kind of a hint for what I'm about to show you, but animation just think of a film like it's just a bunch of different pictures shown to you very quickly. Just a bunch of images that are being projected and shown to you super quick. And every different image is called a frame. And the faster that the images change, that means that you have a faster frame rate. And it might look choppy if you don't have a fast enough frame rate. Okay, so that's all I want to show you there. So if you were going to model a ball bouncing, maybe it starts here, that would be your first frame, and then it's gone up a little bit. Maybe you did this in school, like made those little flip books, right? And then it's suddenly, like if this is frame 1, this is frame 2, this is frame 3, it's starting to bounce. Okay, so that's essentially what we want to do. So sorry, not first. Let's just make a ball that gets dropped and keeps bouncing. We're gonna need some physics though to make it look right. But first, let's just do it without the physics. So let me make a new. Oh gosh, I guess I want actually that rectangle for a second, because I'm gonna do this. So let's make a screen to draw on. Okay, so I can close that. I can close this in theory. Balldrop.py. So I'm first going to draw a rectangle that is white, and that will be our picture frame that we look through. We'll draw the screen, I guess. And it'll be the same width. So starting at, I don't know, negative 100, 100, let's try that. Negative 100, negative 100. Let's draw a 200 by 200. Sorry. 100, 100. I'll show you why. I just want it to be centered. Draw a white rectangle. Let's see if this works. Okay, I think we could make this even larger. Let's do maybe 200 by 200. Or doubled, that's 400. On each side. Okay, because up here is, if 0, 0 is the middle, negative 200, positive 200. So this can be our screen. And then we want the ball to start right here. And let's, we're actually going to use the turtle as the ball. So, this is going to get interesting. We can change the shape of the turtle. I mean, it started as like an arrow, we changed it to a turtle, but we can change the turtle to be something else. Shape. There it is. We can say that the turtle shape can be a circle. Ooh. Let's see how far that gets us. That's a circle. It's a white circle, but maybe we want to let's make it a black circle. So we'll fill. Let's set the fill color, and that'll change the color of the circle, I think. Let's try that, and let's make the turtle go fast because we want to get this moving. Okay, we got a black circle, and we want it to start at coordinates. This is our bounding box. It's 200. So we want the turtle to start right here at 0, negative 200. Okay. So let's have the turtle start there. Pick him up. So it doesn't draw anymore. He's just going to be a bouncing circle now. So it's 0, negative 200. Okay, cool. So now that's our bouncing ball. I guess technically, because the turtle has some width. I'm not sure how much. It's probably like 10 or something. Let's try and see. There. Let's just keep him there. It's easier. Easier to explain this way anyway. So this will be our circle. It is going to bounce. So now we need to talk about how to get this thing to move. So we want to have something happen each frame. Okay? So we want to move the turtle that is the ball ever so slightly each frame. Okay, so that's essentially what we want to do. Okay, ever so slightly we want to move the turtle, and so let's make a move function maybe. Let's make this happen. So I'm not so. Oh, the window's just huge. Let's make a move function. So we can call it. Let's say def. I'll make the function up here. Why not? Move turtle. Or handle bounce. I don't know what I want to call this yet. Let's say next frame maybe. Okay, so the job of this function is going to be move the turtle ever so slightly in the direction we want him to bounce. Let's just pretend at the very beginning he's always going up. So we need to change the turtle's current coordinates. Current y coordinate, that is, to be a tiny, tiny bit more each frame. Because if that means he starts here, we'll move him just a little bit so it looks like he's moving up. Okay, and each frame he'll get higher and higher. Okay, so let's just move the turtle ever so slightly up right now. Let's just pretend he's always bouncing up. So how do we get the current coordinate of the turtle? Okay, so we can set the y. We're going to definitely do that, or use goto. But how do we get the current position of the turtle? Well, that's the position function down here. We can say turtle.pos or turtle.position to get the xy coordinates of the turtle. So turtle.position gives back a tuple actually, and you can assign to a tuple just like this. You can actually get things out of it at the same time as you assign to it. So we can say current x, current y is the turtle.position. So we got it out. And so let's change the current y by a little bit. So turtle.setY current y plus a tiny, tiny, tiny amount, maybe 1. Let's try 1. Want him to move up. So let's call this function next frame to move the turtle ever so slightly. We can't see what happened because he maybe moved a tiny bit, but we didn't see it. So let's do this multiple times. Next frame. Ooh, we have a levitating circle now. Levitating turtle secretly. Isn't that cute and cool? Okay, that's nice. We obviously want to do this for as long as time. So let's just say while, and then say true. And this will loop forever. We'll have to close the program if we want it to stop. Ooh, it's like the moon rising, but the moon is black. and he's gone. Okay, so now we can stop the program. Well, that's nice. If we want him to move faster, and we can change this 1 to a 2. Now he's going to move twice as fast. Whee! That's not bouncing speed yet, though, is it? Let's try 5. Oops. 5, please. I think I accidentally pressed F5 instead of 5. That's more bouncy. Okay, I'm fine with that. And then, okay, the turtle shouldn't always bounce up. Okay, we need to stop him once he hits the ceiling. In our case. So this is like simple bouncing at the moment. So we want to increment the current y by 5 up if the turtle needs to go up, but otherwise, if we've passed the wall, we shouldn't. So we need to keep track of the direction of the turtle now. Okay? So let's make a variable outside of everything called turtle's direction. So right now, we need to go up by 5. Let's change this to turtle direction. And it's just an offset. So it's an offset. So we want to go up by turtle direction as much as we can until we hit the wall. So if we ever hit the wall, we need to change the direction. If the current y is greater than or equal to 200. Okay, that means you've hit the wall. And then we need to change the turtle direction to the other way. Equals turtle direction times -1. So now it'll be -5. The turtle will go down by 5 when we add this offset. You see that? So if the turtle hits the wall, go down by go in the opposite direction. Change the offset to be negative. Okay. Oh, I think I've done something wrong. Reference before assignment. Did I spell something wrong, maybe? This is going to be something that I have to say this, I think. Because I'm setting it. Is that going to work? Yeah. So this right here, it's a little hack, but this tells Python that turtle direction is a variable that exists outside of this function. It's a global variable, we call it. Okay, so now it'll work. And when we run this, it'll bounce off the top wall, but then go down forever. So we need to do it in the opposite direction as well. Okay? So in either case, hits a wall, we need to go in the opposite direction. And -1 will always work. It'll make 5 -5 and make positive, and -5 +5. So if it's going too far up or too far down, then we need to go in the opposite direction. And just to make things easier, let's do strictly less than and strictly greater than. And so now if it goes too far in either direction, we want to stop this. Whee! And so now we have a ball that is bouncing at the same speed. Okay, so there's not enough time to go and add physics yet, because I want it to drop like it would in real life. But this is a good start, and let me show you how to customize all this stuff. So the ball's color is dictated by the fill color of the turtle. So we can make it pink if we wanted to. So now it's a pink ball that's bouncing. And you can also change the size of this ball by doing the following. We can make it a larger ball by changing, I think it's the turtle size, potentially. It's one of these two. It's either shape size or turtle size. We're going to figure this out. No, I guess they are the same thing. Never mind. So we'll say turtle.turtle size, and then we need to stretch it along its width and its length by the same amount to keep it being a circle. So I think we should be able to say turtle dot, well, let's make it twice as big, turtle size 2 in each direction, so increase width by 2, height by 2. Okay, now I have a larger ball. You see that? And you know how to make it go faster or slower. That's just the direction. This offset, a larger offset means a faster moving ball. Okay, and of course vice versa. So we can make the ball move very slow with a 1, just levitating. It's like it's a pink moon now, and it's rising and setting. Also, we can make it just as fast with like a 5. All right, so those are your options at the moment, and this is what I'm going to get you started with for your next programming assignment. So this will be your starting point, and let me go write that up, and I'll be right back. All right, it is time for your programming assignment, and then we'll get you out here. So let me make this large. You will be doing most of what I just did, so you'll still have the ball, it'll still be bouncing up and down, but you're going to do fancy things. The ball is bouncing on magic walls, we'll say. So here's what you need to do. Again, you'll draw the bounding square to represent the walls. You'll make the ball bounce up and down like we've done. So you can reuse all of that code. And then the new thing that you need to do is randomly make something weird happen each time the ball hits a wall. So it's coming down, it hits a wall, it needs to do something weird. And it bounces up, it hits a wall, it needs to do something else weird, randomly. So you're going to make a new function called do something weird, or some other name that's similar. And that function, you're going to randomly pick a weird thing to do. Okay, so each time your ball hits a wall, so somewhere here, think of where it needs to go, somewhere in this function, you're going to call this function, and it's going to randomly pick something weird to do. Okay, it'll randomly pick one thing to do that's weird each time the function gets called, just like that. And you need to program at least 3 different weird things. And here are some ideas in case you're interested. You could, when a ball hits the wall, change its color to a random color. You know how to do that now. You can change the size of the ball by a random factor. And if you want to get random factors that are floating point numbers, that are floats instead of ints, you have to use random.uniform. Okay? That looks like this. Because normally you used random.randint. You gave like 1 and 7. That just gives you whole numbers. Like you can't plug in 7.5 here. Random.uniform is the equivalent for floating point values. It'll give you a random value in between those things. So that could be useful. You could change the x coordinate of the ball to a random one to make it teleport, like it was bouncing in the middle and now it's over here after it bounced once. So that would be fun. You can change the speed of the ball. You know how to do that, definitely, by some random factor, or just always make it super slow, or make it randomly super slow or super fast, who knows. You You could randomly change the shape of the turtle. You know how we make it a circle. You can make it back to a turtle, maybe. You can make it a different thing that the turtle module has, like the shape. Could be a square or a triangle, or a turtle, or an arrow. Don't know what classic is. Might be another turtle shape. But yeah, have fun with that. Get creative. I'm just testing your ability to write your own function. Okay, this is a function that doesn't return anything. It just does something. Okay, something cool. So make sure to look at the random modules documentation. Same with the turtle modules documentation. That'll be helpful. And yeah, when you're uploading, just as normal, make a video, show me your code, explain it to me, and it'll be due in 2 weeks. So enjoy. Hopefully this is an exciting one. We're finally animating things, so that's fun. All right, so I'll see you later.